First, I will write what is that. I'm going to write the given function. He is given that we have to find the Laplace transform for unit step function, that is f of t equal to u of t. I'm going to write the definition of step function, that is u of t equal to 1 if the value of t is greater than or equal to 0, else it is 0. Okay, let us substitute this value in the definition of Laplace transform. Hence, Laplace transform of u of t equal to integration over the limits. Instead of writing minus infinity to plus infinity, I am going to write 0 to infinity, because the step function u of t is present for what? If the value of t is greater than or equal to 0. Because of that reason, I have taken the limits as 0 to infinity. Hence, f of t e to the power minus st dt. F of t is what? F of t equal to u of t. U of t is what? That is 1. Hence, integration over the limits 0 to infinity 1 e to the power minus st dt. So, integrate this one, e to the power minus st divided by minus s. Limits are infinity and 0. Substitute the limits here. Hence, Laplace transform of u of t equal to, wherever t is there, substitute the limits. Higher limit is infinity, hence e to the power infinity minus divided by minus s, minus of, in place of t substitute 0, e to the power 0 divided by minus s. Further simplification, e to the power infinity, we know that it is 0, so this entire term becomes 0, and left with what? Minus into minus plus, e to the power 1, e to the power 0, that is 1. Hence answer is 1 by s. So we got finally the Laplace transform of unit step function, that is Laplace transform of u of t is 1 by s. Similarly, I will take another standard function Laplace transform, that is find the Laplace transform of ramp function r of t. Okay. So Laplace transform of r of t equal to, that is r of t equal to what? Write the definition of ramp function r of t equal to t, where the value of t is greater than or equal to 0, else it is 0. Hence, substitute r of t equal to what? It is t multiplied by e to the power minus st. Once again, limits becomes, instead of writing minus infinity to plus infinity, I will write, because it is present for what? T is greater than or equal to 0, hence 0 to infinity. Let us make use of this formula. Integration of u v, that is equal to u integration v minus integration of, inside the bracket, differentiation of first function, integration of second function. Okay, u is the first function, v is the second function. Okay, here in case, in this case, u equal to t, u equal to t, v equal to e to the power minus st. So let us make use of this formula. What is that? First, u as it is, u means first function, that is t as it is, integration of second function, integration of e to the power minus st, that is, here I substituted, minus integration, minus integration, inside the bracket, differentiation of first function. Differentiation of first function is t. Differentiate this t with respect to t, we are getting what? Differentiation of with respect to t. Then integration of second function, integration of e to the power minus st. So as per this formula, I substituted all the values. Next, do the simplification. First one, t as it is, integration of e to the power minus st, that is e to the power minus st divided by minus s. So limits are infinity and 0. Next, minus as it is, minus as it is. So differentiation of t, that is 1. Okay, integration of e to the power minus st, that is e to the power minus st divided by minus s dt. So outside the bracket, one more integration is there, so that is this integration comes here, that is integration over the limits 0 to infinity. Next, further simplification, e to the power infinity, wherever t is there, substitute upper limit infinity, e to the power infinity, that is 0. 0 multiplied by anything is 0. Next, second one, second limit is what? 0. Wherever t is there, substitute 0. So 0 multiplied by anything is 0. So this entire term becomes 0. Next, I will take this minus s outside. Minus into minus plus, that is 1 by s outside, because we are performing the integration with respect to variable t. So because of that reason, I have taken outside. Next, perform the integration of what? E to the power minus st with respect to time t. Integration of same thing, 1 by s as it is. Integration of e to the power minus st, that one we are writing it as e to the power minus st divided by minus s. Limits are infinity and 0. 1 by s as it is outside. T, in place of t, write substitute infinity divided by minus s. Minus of, in place of t, substitute 0, e to the power 0 divided by minus s. So e to the power infinity, it becomes 0. Then minus into minus, it becomes plus. E to the power 0, 1, 1 by s. Hence 1 by s multiplied by 1 by s, it is 1 by s square. Laplace transform of ramp function is 1 by s square. Is it clear? Okay, next one. Find the Laplace transform of sine square of t. Given the function is f of t equal to sine square of t. We know that using the trigonometric formula, sine square of t we can write 1 minus cos 2 theta divided by 2. So that one I'm going to substitute here. Laplace transform of sine square of t is equal to, I'm using this formula, that is 1 by 2 minus cos 2t divided by 2. 1 by 2 is constant, take it outside. Then left with what? 1 minus cos 2t. Okay, then apply the Laplace transform. Laplace transform of 1, that is u of t. U of t equal to 1, correct? Already we calculated, that is 1 by s. Then standard Laplace transform of cos 2t is s divided by s square plus 2 square. Hence the answer is 2 divided by s into s square plus 4. So you may ask, so how we got this answer, sir? Already we know the definition. We discussed about the Laplace transform of step function. That one we written as 1 by s. What about cos of 2t? Before discussing this one, uh, already we discussed in the mathematics for network theory, not necessary of discussing those things. So I am going to write one table here. Let us make use of this table of Laplace transform. If the function is 1 and lt means Laplace transform is 1 by s. If the function is constant, then k by s. If the function is t, then 1 by s square. Then if the function is f of t equal to t to the power n factorial divided by s to the power n plus 1. If the function is e to the power minus at, 1 divided by s plus a. Similarly, e to the power at, 1 divided by s minus a. E to the power minus lt multiplied by t to the power n. Then we are writing n factorial divided by s plus a. The power term is n plus 1. Sine of omega t. See here, already we discussed previous example. In place of omega, sorry, this one. Sine of omega t is what? Omega by s square plus omega square. Cos of omega t. See previous example. In place of omega, 2 is there. So what we are writing? S divided by s square plus omega square. Omega is what? In the previous example, 2 is there. 2 square. Similarly, next one. E to the power minus at sine omega t. That is omega divided by s plus a square plus omega square. So likewise, you can refer this table, because as per your syllabus of network theory, we are dealing only about the networks. All these things already maybe you discuss in the mathematics part, so not necessary to discuss all these things. Only we are finding the Laplace transform for the networks. Okay, one more standard function, that is Laplace transform of uh, impulse function. Find the Laplace transform of impulse function. Impulse function is what? Delta of t. F of t equal to delta of t. Delta of t is what? 1 at time t equal to 0. Substitute. We know that one relation. Delta of t is what? Already we discussed. Delta of t is what? It is the differentiation of u of t. Hence, delta of t equal to, we can write differentiation of u of t. Already we discussed properties of Laplace transform. Laplace transform of differentiation of function, that one we are writing it as s into f of s minus f of 0. Here f of t equal to what? F of t equal to u of t. Compare these two things. F of t equal to what? U of t. So using this property, directly I am writing the answer as s as it is, s as it is, s as it is. Laplace transform of what? F of s. F of s means f of s stands for Laplace transform of f of t. F of t is what? U of t. Laplace transform of u of t is what? That is 1 by s. Already we discussed. Minus f of 0. F of 0 means at time t equal to 0. At time t equal to 0, u of t is 0. Hence 0. So the Laplace transform of delta of t is 1. This is about. So we discussed up to now Laplace transform of impulse function, step function, ramp function. We will move on to the networks, waveforms. Okay. Find the Laplace transform of the following function. These kind of examples will appear for the examinations. See, he is given one function f of t that is represented graphically as first. For these kind of examples, first step is we have to express the given function in terms of mathematical equations. Then only we can easily calculate the Laplace transform for the given function. So this point you have to remember, for the given function, graphical function, first you have to write mathematical equation. See here, f of t, the function f of t has amplitude 1 for the duration t equal to 0 to t. From t equal to 0 to t, it has amplitude 1. For other values, it is 0. For other values, it is 0. Only this amount of amplitude is present at time t equal to 0 to t. Hence, I am writing f of t equal to amplitude is 1. This amount of amplitude is present for the duration where the value of t, lies between 0 to t. So I return this function in terms of mathematical expression. Then apply the Laplace transform for this f of t. Laplace transform of f of t equal to use the definition of LT, that is minus infinity to plus infinity f of t multiplied by e to the power minus st dt. So instead of writing the limits minus infinity to plus infinity, I will write the limits as f of t is present. F of t is present. It is present where only for this duration. So lower limit is 0, upper limit is t. F of t is what? F of t is 1. I substituted here. Then left with what? E to the power minus st dt. Then remaining part is simplification. Integration of e to the power minus st. That is what we are getting, e to the power minus st divided by minus s. Limits are t 0. Next step for the simplification. Wherever t is there, substitute the upper and lower limits. First one, upper limit, t is small t equal to capital T divided by minus s as it is, minus of, in place of t I will write 0, e to the power 0 divided by minus s. Then e to the power minus st divided by minus s as it is, minus into minus, it becomes minus into minus, it becomes plus. Okay, in the coming steps I am going to write same thing I written here. E to the power 0 is what? 1. It is minus of 1 divided by minus s. Now further, minus into minus, it becomes plus 1 by s, plus 1 by s, minus e to the power minus st divided by s. Hence the Laplace transform of this function is 1 minus e to the power minus st divided by s. Okay, this is a very simplest example. Let's move on to the next one. Find or obtain the Laplace transform of sawtooth waveform. This is the sawtooth waveform is asking for find the Laplace transform for this function. As I told for the previous example, first these kind of examples if you got, then in order to calculate Laplace transform, first step is we have to express the given function in terms of mathematical equations. So it is not constant. In the previous example, the amplitude is constant, so directly we return the value. But in this case, see here, the amplitude of this function f of t, it keep on increasing. At time t equal to 0, 0 is there. At time t equal to 1, something is there. And time t equal to 2, something is there. So comparing with the previous times, the amplitude is keep on increasing. We don't know exactly what it is. Okay, because of that reason I am going to make use of straight line equations. I am going to find the amplitude over the time 0 to t, how much the function f of t has its amplitude. In order to calculate, I am making use of straight line equation. So for that straight line equation, I am going to represent these two ends. Straight line means joining two ends. These two ends I am going to represent in terms of coordinates as, see here, this point I am going to represent as a coordinates x1 y1. This point I am going to represent as a coordinate x2 y2. Okay, two ends are there. Now coming to the first point, this point, coordinates are x1 y1. What is x1 value? X1 means x axis, y means vertical axis. X value is what? 0. X1 value is 0. Then y1, that is also 0. So coordinates are 0 comma 0. Next coming to this point, what is the x2? X2 means this point, horizontal axis. T is there, and y2, how much? A is there. So I represented the coordinates of these two ends, these 2 points, as x1 y1, x2 y2. Now write the straight line equation. Using straight line equation, I am going to write as y2 minus y1 divided by x2 minus x1, that is equal to y minus y1 divided by x minus x1. Substitute the values. Y2 is how much? Y2 is a minus y1 is how much? Y1 is 0. Divide by x2 is how much? X2 is t minus x1 is how much? X1 is 0. So simplifying, a by t, y by, next, okay, this one we substitute. Then coming to here, y minus y1, y as it is, y1 is how much? 0. X minus x1, x1 is 0. Hence after simplifying, a by t equal to y by x, a by t equal to y by x. Hence y equal to a by t multiplied by x, where y stands for what? F of t. Y means vertical axis, nothing but f of t. X stands for horizontal axis, it stands for, it is nothing but here y equal to f of t, x equal to t. Then this equation we can write y nothing but f of t equal to a by t multiplied by t. Hence the given function we represented mathematically as like this: f of t equal to a by t, capital T, multiplied by t. This amount of amplitude is present from where? 0 to t. Hence we will write the value of t lies between 0 to t. So this one I have done here. F of t equal to a by t into t, where the value of t lies between 0 to capital T, else it is 0. Next, for this one, simple thing, apply the Laplace transform. Let us make use of definition of Laplace transform. Laplace transform of f of t equal to, instead of writing minus infinity to plus infinity, I am going to write the limits as 0 to t, because this function has its amplitude only for this time. Because of that reason, I am writing as limits as 0 to t, where f of t is what? A by t into t e to the power minus st dt. Where a by t is a constant term, take it outside. I have taken the outside. Next, 0 to capital T, integration over the limits 0 to capital T, t into e to the power minus st. Okay. Next, here I am going to make use of integration by parts. I will substitute first, that is a rule. Already we discussed in the previous example. I will consider t as a u, and I will consider second function e to the power minus st as a v. By using the formula, this formula, integration of uv equal to u first function, u nothing but first function, integration of second function minus integration of inside the bracket we can write differentiation of first function, then integration of second function. Use of this equation, I am going to simplify. Laplace transform of f of t equal to a by t, as it is constant outside. Next, coming to this one, u means what? T. Integration of v. Integration of v means second function. Integration of e to the power minus st, we can write e to the power minus st divided by minus s. Limits are t0. Substitute minus integration as it is inside the bracket. Differentiation of first function, differentiation of t, that one. Then integration of second function, that is e to the power minus st. So it becomes divided by minus s. Okay. Next step, a by t. Substitute the limits. Upper limit is t, lower limit is 0. Wherever small t is there, substitute capital T. So capital T e to the power minus s into capital T divided by minus s, minus of lower limit. Wherever t is there, substitute as a 0. So in place of t, substitute 0. 0 multiplied by anything is 0. Next, minus So this is integration of what, e to the power minus st by s is there. S is constant, I will take it outside. Minus into minus, it becomes plus. 1 by s I have taken outside. Then integration of, left with what, e to the power minus st. Integration of what, e to the power minus st. Then further integration, e to the power minus st divided by minus s. Limits are t 0. Next, a by t as it is. Then t into e to the power minus st divided by minus s as it is, plus 1 by s as it is. Now substitute the limits. E to the power minus s t divided by minus s minus e to the power minus s multiplied by 0, it becomes 0. E to the power 0 divided by minus s. Further simplification, Laplace transform of f of t equal to a by t constant outside, t into the power t multiplied by e to the power minus st divided by minus s plus 1 by s. Then simplifying, then we are getting 1 by s minus e to the power minus st by s. Now further simplification, mathematical simplification is there. A by t as it is, this term as it is. Now multiply this one, the terms which are present in the square bracket. 1 by s multiplied by 1 by s, 1 by s square, plus into minus minus e to the power minus st divided by s square. Hence what we taken here, we taken s square t common. Hence Laplace transform of f of t equal to a by s square t. If we take s square t denominator common, so left with what, this one, 1, then minus e to the power minus st, then minus st e to the power minus st. This is the what, Laplace transform of given function. So likewise, for the given functions, we are going to calculate